So today we are going to discuss the problem number 21 of LeetCode, merge to sorted list. And to find these problems, you can just Google it up, that merge to sorted list or LeetCode problem number 21. It will come up. Yeah. So what we are provided with two linked lists. This is our linked list 1 and this is our linked list 2. And we have to merge the two sorted linked list. So it is very clear to us that linked list which will be provided to us will be always sorted. So 1, 2, 3. This is also in a sorted manner, and 1, 2, 4. This is also in a sorted manner. So now we have to merge them, right? In a sorted manner. So 1 will come. Now after this, again 1 will come, right? Now after this, 2 will come. Then I can say again 2 will come, and then 3, and then 4, right? So this will be our output. So let's see how we can achieve this. Let me draw it again, and let's do step by step how we can achieve it. So I can have a very simple approach that which one? 1, 2, 3, and 1, 2, 4. So what I can do, I can copy this in an array, right? I can copy this one also in a vector or array. Or for in Java, we have array or lists. So now what I can do, now I can create one more array from this array, right? I can create one more, I can append all this, I can append 1, 3, and then I can append, and then I'm gonna apply sort into this list. 1, 1, 2, 2, 3, 4. I can sort this array, right? uh, and then I can clone this linked list, clone this into a linked list. I can first create this node, then uh, point this one next to this one, clone this one, and then this one, right? That's how we can do it. So that is also one way. But what will be the time complexity to achieve this one? So time complexity will be, so you are cloning this, right? Cloning the, so you're traversing all the list, right? So you can say of n plus this one also of n. Then again to clone this both, you will be traversing again. Let's say the length of this can be of m, right? This one will be of n plus n. And then to sort this merge list, merge array, what is the mean time complexity? That is n log n, right? So in this case, it will be, my bad, m and this m, which will be O of n plus m into log of n plus m, right? And then again, I will be traversing it. So of n plus m to clone this into my linked list. So effectively, I can say this is the largest, right? So this will be my time complexity for this one. So of plus m, right? And it was space complexity. To clone this, we already know that auxiliary stack space of n is required, plus we will be needing the array, we will be needing the array for second list and the combined array, right? So let's find out if there is any more better approach than this approach, how we can do this one. So let me discuss my approach to here. What if instead of creating an array, I just directly merge my linked list one after another? So what the idea is, I will take one, right, and I will compare the current position of each linked list. My current will be initially at head, and then I will compare which one is smaller one, right? So I will put the smaller one, and then I will move the smaller one to the next one. and then I will compare again, and that's how I will do comparisons and put in my new linked list. So what I will do, let me write the step one. Let me write one, two, three, one, two, four. Yeah. So my current is here, current one, and my current two is here. I said I will do. I will compare which one is the smaller one. I will put it. So they both are equal in this case. So I can take any one, right? And then I will move in. I will get this new pointer. I will move this to next position. Go here, right? So let me write step two. One, two, three, and one, two, four. And now my current two is here and current one is here. And in my list, let me make a list here. Let's say my output is being here, right? So now, if we compare current one and current two, my current one is smaller, obviously, right? So again, I will put one here, and then I will move this one to this position. Okay. Now I will write step three here. So in step three, one, three, one, two, three, two, four. Right. So this is here, this is here, and what I will do, I will compare this, and I will say that my current two will move to four because they both are equal, and this will be as it is, and I will put my two here, right? And now again, step four. What I will do, step four. Let's see. One will be here, two will be here, three will be here. One, two, four. So my current two is already at four, and this one is also at two. No, still at two, right? So my current one is smaller than two, right? So I will just put it here, and then I will move my this one to the next part. Okay. Okay. Now let's move to the next step. Now our current one is at three, and current two is at four. So what we will do now? Step five. Step five. What I will do, I will compare 3 with 4. 3 with 4. 3 is smaller, right? I will put 3 here. And then this will move to the next one, which is null. So as soon as I move null, right? As soon as I move null, there is nothing which I can move from here. And my list is sorted, right? So I can directly place this. I can directly place this behind this one. Similarly, for this one, if my this will be exhausted first, then I can directly put list one elements behind this one. Now I achieved my output merged sorted list in a single iteration, right? And by just using an space of new list, right? Which we have to do. That is very critical for us. So now the problem here is that your this we made one head, right, and then we kept moving this head to next and next, right? So now I have lost my head, which I have to return my answer. I have lost it because my head is currently pointing here. So how will it trace back to this position? For that, what we will do, we will create a dummy node of -1, and I will point that to the next, and I will store my dummy node somewhere. And while giving my answer back, what I will say that give answer of dummy nodes next. That is my head. Yeah, that thing is also clear. Now let's discuss the edge cases. So, so if my list one is empty and I have given a list two, right? So I will just return my list two, right? We'll just return my list two. That is one edge case. If list two is empty, list one is given, I will return my list one. If both are empty, I will return none. Okay, that is also very clear to us. So now let's write the pseudocode for this. It is like if our list one is not null, right, and list two is null, I will return my list one. If list one is null and list two is not null, I will return my list two. If list one is also null and list two is also null, right, as we discussed, then also I will return my null. Now we have to make a dummy node, right? So dummy node equal to new minus one star head will be pointing to new head, right? The head of our new linked list which we are gonna return to dummy node, and then our current one will be pointing to this one, and current two will be pointing this two. Now we have to run a while loop over it. If current one exists and current exists, right, until they are not null. I will keep on iterating, and if current one value is greater than current two's value, so I'm saying my heads next will be smaller one, right? What is smaller one? Current two, correct? And current two, and now my head will current two, right? My head will current because its next is current two itself, and current two will be equal to current two's next, correct? Else else current if my current two is greater one, right? So my current uh the scenario my current one is smaller, right? So head one next is equal to current one, head is equal to current one as it will move to the next position, and current one will move to its next, correct, as we discussed. And then while loop will close here. And if my any of the elements are left in current one, this is not equal to null. What I have to do? I have to point my heads next to current, and if current 2 is not equal to null, similarly I have to point my heads next current 2, correct? And then we will return our answer, and the answer is dummy next, correct? So these are pseudocode, guys. I hope this is very clear to you. We are just using the edge cases. If one is empty and other has the data, then return that one, and then if both are empty, then we are returning a null. Then we are making a dummy node, and then we are making a head, and then we are just making the reference pointer to the linked list provided to us, and then we are iterating over those and keeping track of the smaller one and adding them in our new linked list, and then just if any of the list is left, adding it behind the list, and then returning our new head, right? So let's code this up quickly and let's see what will be the result. So what we have to do, list star current one is equal to list one star current two is equal to list. Great. So let's first code our edge cases also. If list one is equal to null and list two is not equal to null, then return two. Here I will return list one, my list one data, and then these both are equal to null, then I'll just right. So edge cases are covered. Let's make a dummy node. Which is equal to new list minus one, and then that will be equal to dummy node, right? And while iterate, we will keep iterating until our current value is null or current list, right? And done the next, right? And if any of the list is empty, right? After the iteration, then what will I will mark the heads next is equal to current one, and if here it is empty, this list is empty, then similarly for this one. And now let's write our logic here, uh, taking the nodes. If current one's val is greater than current two val, right? Else, so what I will do here, I will move my heads next to current two, right? As my current one is greater, and head will be eventually moved and two, and current two to next. Similarly, here that will be equal to its next will be current one, as current one is smaller here, and current one will be to current one's next before moving to the small word to right. Let's just quickly run this problem. Let's see if our test case is given in the passing. All tests are passing. Let's submit this code to see 100% time complexity, and this is the fastest solution. And if you are not clear, just drop a comment below. I will try to explain to you, and try watching the video one more time if there is some confusion to it. And guys, please do like, share, and subscribe. That means a lot. It helps me keep going on. And Thank you for watching this. I hope you enjoyed.